Robot. This Zoom session is being brought to you by the fractal set of itself. All right. Today's session is about sections 1.3 and 1.4, about signed number arithmetic and simplifying algebraic expressions. So, okay, for 1.3, we'll be adding, subtracting, multiplying, and
Yeah, I just need the paper.
sorry.
That's okay. I think I fucked up. It should have.
I'm sorry. Is someone saying something? Okay, never mind. Um, signed number arithmetic. So we'll be adding, subtracting, multiplying, and dividing signed numbers. That'll be plus, minus, and 0, of course. All right, now for adding signed numbers, let's add signed 5 and 3, and also with 0. Now, here we have 5 plus 3 is 8, and minus 5 plus minus 3 is minus 8. These have the same sign, so they pull in the same direction. So you add the absolute values and affix the common sign. 5 plus 3 is positive 8, negative 5 plus negative 3 is negative 8. Here we have opposite sign, negative 5 plus 3 and 5 plus negative 3. They pull in opposite directions, so you subtract the absolute value. So negative 5 plus 3 is negative 2. 5 plus negative 3 is positive 2. Why a negative 2 for this one and a positive 2 for that one? Someone wanted to say? Why is this one negative 5?
Because you're starting with a negative.
Well, it's not the order in which you add. It's that 5 is a bigger number in absolute value than 3 is. So the larger number had a negative in this first case, and the larger number 5 has a positive, so it's a positive in the second case. So you fix the sign of the bigger number, let's be precise, bigger in absolute value. Now for these, 5 plus 0 is 5, 0 plus negative 3 is negative 3, and 0 plus 0 is 0. It's simply that if we take a number and add 0, you get the same number. This is called an identity. Adding it keeps the number identical. Okay. If you have a list of signed numbers, such as here, then one shortcut is to add all the positive numbers together, then all the negative numbers together, then add the two results. So 1 plus negative 2 plus 3 plus negative 4 plus 5 plus negative 6. The positive numbers are 1 plus 3 plus 5 here, which add up to 9. The negative numbers are negative 2 plus negative 4 plus negative 6 here, which add up to negative 12. And now we add these two by subtracting absolute values. 9 plus negative 12, the difference is 3, and 12 is a bigger number, so this is negative 3. You define subtraction of signed numbers by a minus b as a plus the opposite of b. So, and double negative cancel, so minus negative 3 is positive 3. So you have the same things, signed 5 and 3, and then with 0, and we subtract them. 5 minus 3 is 5 plus negative 3. Opposite signs, we take the difference, and it's positive because 5 is bigger. 2. Negative 5 minus negative 3. Now, a double negative cancels, so it'll be negative 5 plus 3. Again, opposite sign, they pull in opposite directions, so we take a difference. And 5, the bigger number, has a negative, so the result is negative 2. Negative 5 minus 3, that's negative 5 plus negative 3. They're pulling in the same direction, negatively. And you add the values to 8, so the result is negative 8. 5 minus negative 3, that's 5 plus 3, or 8. Now, okay, 5 minus 0 is 5 plus 0, because 0 is its own opposite, and 5 plus 0 is 5. 0 minus negative 3 is 0 plus 3, or 3. 0 minus 0 is 0 plus 0 is 0. So here's some examples. In general, a number minus itself is 0. A minus a is 0. Now watch out, a minus negative a. You can get lost in all the negatives. Here they cancel. That's a plus a. That's 2a. Minus a, well, that's minus 2a. You go backwards a steps twice. And here, negative a minus negative a. That's 3 negative signs in a row. People get confused. But think of it as a number minus the same number. A number minus itself is 0. Here too. Also, you can rewrite this as negative a plus a, which again is 0. In general, if you have a subtraction a minus b, that'll be the opposite of the subtraction in opposite order. So, for example, 2 minus 7 is negative 5, and 7 minus 2 is positive 5. So the two opposite subtractions have opposite sign. Now we go for multiplication. Sine 5 and 3 along with 0. Let's multiply them. 5 plus 3 is 15. That's easy enough. Negative 5 plus negative 3. These have the same sign. So in both cases, we affix a positive. Negative 5 times negative 3 is, again, positive 15. Here they have opposite sign. Negative 5 plus 3, 5 plus negative 3. In both cases, we affix a negative. So therefore, negative 15 for both of these. And for all of these, x times 0, whatever x is 0. 5 times 0 is 0. 0 times negative 3 is 0. 0 times 0 is 0. 0 of anything is the same 0. So you can make it kind of a times table. If you're multiplying plus 0 or minus times plus 0 or minus, then, well, okay, plus times plus is plus, plus times 0 is 0, plus times minus is minus, this way and that way. 0 times anything is 0, so you get all these zeros here. And minus times minus is plus. Now, oh, who just joined us? I'm sorry, I wanted to put your name on the.
Hi, my name is Jocelyn Barrera.
Jocelyn, who?
Barrera.
Barrera. Okay, gotcha. Thank you. All right, now for dividing, here it gets a little tricky. A is equals B divided by C if and only if, we symbolize if and only if by this double arrow, if and only if A times C equals B. In other words, the ratio B over C is what you can multiply which times C, the denominator, equals the numerator. So B over C is the solution to B over C times C equals B. So B over C is what times C equals B. So for example, 15 over 5. Well, okay. Well, what times 5 is 15? 3. So 3. Negative 5 divided by negative 15 divided by negative 5. Again, what times negative 5 is negative 15? Well, again, positive 3. 3 times negative 5 is negative 15. Negative 15 divided by 5. What times 5 is negative 15? Negative 3. So here we go. 15 divided by negative 5. What times negative 5 is positive 15? Negative 3. Negative 3 times negative 5 is 15. Now the next few are a problem. 0 divided by negative 5. What times negative 5 is 0? Well, 0. Thus, 0 times negative 5 is 0. These, however, trying to divide by 0. What times 0 is 15? Ooh, that's a problem. I don't think there are any such numbers. And what times 0 is 0? Well, any number. So these have a problem. 0 times x equals 0 for any x. So these have some difficulties in solution. This seems to have no solution, and this seems to have any number as a solution. We'll get it, and as a result, division by 0 is a problem, and we'll be getting into that a little later. It doesn't result in normal numbers, you see. Non-zero divided by 0, let's say 1 over 0, or 2 over 0, or 3 over 0, what have you. This has a special name. It's called infinity. It's denoted by the sideways 8, aka a lemniscate, meaning bean. And if you actually try and divide 1 by 0 in a long division, okay, 0 divided into 1, we take away 1 0 from 1, it still remains a 1. Take away another 0 from 1, it still remains a 1. Take away another 0, it still remains a 1, and so on forever. I call this a cycle of futility. So whatever this infinity is, it is not 1, nor 2, nor 3, nor 4, nor etc., any finite number. It's too big to be a normal number, and therefore it's caused all sorts of trouble. Now, if you take 0 divided by 0, that's called the indefinite ratio. I call it indefinity. That's my name for it. It doesn't have a name of its own. It doesn't have a symbol of its own, which I think is a shame. And so I use this kind of I think of it as a sort of an infinity sign turned inside out like a sock. This shape is called a cardioid, meaning heart-like. Now, if you divide 0 by 0, well, you take 1 0 away from 0, you got a remainder of 0. Good. But if you took away another 0 from 0, it would still be 0. If you took away a third 0, it would still be 0, and so on. So it's constantly already at the 0 remainder you want a division to yield. So this is, I consider, a cycle of redundancy. So 0 over 0 could be any of these numbers, any finite number. So it's too vague to be a normal number. I think of dividing 1 by 0 as trying to ride your car a mile when the clutch is popped. No matter how you rev the engine, you won't get anywhere. And here, dividing 0 by 0, your clutch is still popped, but you're already at your destination, so you could rev for a minute or no minutes or 100 minutes, all the same. Okay, so these are problematic. All right, so you divide for signs in 0. Plus over plus is plus. Plus over 0 is infinity. Plus over minus is minus. 0 over plus is 0. 0 over 0 is indefinite. 0 over minus is 0. Minus over plus is minus. Minus over infinity is over 0 is infinity. And minus over minus is plus. Now, the book and I have slightly different attitudes. The book is afraid of division by 0. They call it undefined. They call it an illegal operation. Oh my goodness. I allow infinity and indefinite. You do have to distinguish them from each other. I'd rather you did that. Because like I said, this infinity is something where there's no solution. And the indefinite is where everything, too many things are a solution. We'll be seeing that later when we try and intersect lines. Parallel lines intersect at infinity. Overlapping lines intersect at the indefinite ratio. In other words, everywhere. So that's more for that. Now let's be talking about exponents, the arithmetic of exponents. X to the power n is, you start with a 1 and you multiply by x n times. This x is called the base. This number here is called the exponent. Square root, y equals square root of x, if and only if y squared equals x. So if you have a square with area A, then the side, for some reason called the root, is the square root of A. So for example, a square with area 4 has side 2. So the square root of 4 is 2. A square with area 9 has side 3. So square root of 9 is 3. Now, sometimes if you have all these operations, which comes first, the order of it makes a difference. For example, 1 plus 2 times 3 to the 4th versus 1 plus 2 parent times 3 parent to the 4th. Now, so these parentheses are basically guiding which to do first. Here we do the 1 plus 2 first. That's a 3. 3 times 3, well, we do that before the 4th power. 3 times 3 is 9. 9 to the 4th power is 6,561. But usually, so when you do something, you always do the innermost parenthesis first. But if there's no parenthesis, we have an order of operations convention called PEMDAS, meaning PEMDAS. P for innermost parentheses first. And within that parenthesis, E, exponents first, before times or divide or addition or subtract. Then after you do the exponents, you do MD, multiplications and divisions from left to right. Then after all that's done, you do AS, additions and subtractions left to right. So I think of exponents as binding tightest, multiplication and division binding not quite as tight, and addition and subtraction is loosest. So for example, 1 plus 2 times 3 to the 4th. Montiel, excuse me. All right, 1 plus 2 times 3 to the 4th. There's a plus, a times, and an exponent. We do the exponent first, 3 to the 4th. That's 81. 1 plus 2 times 81. A plus and a times, we do the times first. So it'll be 1 plus 162, and that makes a 163. Now, here I use parentheses to do it in the opposite order. First the times, plus then the times, then the exponent. And with the result that it's a very different result. Order of operations counts. Here's some examples. Negative 3.3 minus negative 3.3. Well, that's the same, a number minus itself, or you can write this as minus and negative is plus. Negative 3 plus 3.3, they cancel out, 0. Negative 3.3 minus 3.3, you can write that as negative 3.3 plus negative 3.3. They have the same sign, so they pull in the opposite direction, a negative direction. And so these add up to negative 6.6. Here we have negative 0.3 times 5. There's only one negative there, so the result is a negative, negative 1.5. Negative 0.3 times negative 5 minus a negative cancels out. Odd, even, and so on. So it's plus 1.5. Now here we have a bunch of such things, bunch of numbers multiplied. If you want to multiply the numbers, you put a positive sign if they're evenly many negatives, and you put a negative sign on if they're odd many negatives. You have negative 5 times 6 times negative 2. An even number cancels out, so you get positive 60. Here, negative 5 times negative 6 times negative 2, that's 3, an odd number of negatives. So, and then 5 times 6 times 2 is 60, so you get a negative 60. So multiplication and also division by sign numbers goes by a parity rule. Plus, minus, plus, minus, plus, minus, plus, minus, and so on. She loves me not. Here we have fractions multiplied. Okay, first of all, there's the matter of the opposite of a fraction. You can write that as minus 3 over 5. Or 3 over negative 5. They're all the same. I personally prefer this one, putting the negative in the numerator, because when you put the negative right outside the fraction, there's a danger that you might, in your haste, write them so swiftly that the negative sign and the divide sign merge into each other, and right away you made a mistake. So I prefer this as for legibility's sake. So negative 3/5, right, is negative 3 over 5. That times 10 over 7, fine. You multiply by multiplying numerators and denominators, negative 3 times 10 over 5 times 7. However, 10 and 5 have a common factor of 5. If we cancel them, we're left with a 2. Negative 3 times 2 over 7 makes negative 6 over 7. Here you have 84 over negative 6. Well, it's the opposite of 84 over 6, and 84 over 6 is 14, so a negative 14. Here we have a negative 84 over negative 6. Again, even number of minus signs cancel out. So this becomes 84 over 6 or positive 14. Here again, we have a negative over a negative. They cancel, 10.8 over 1.2, or in other words, positive 9. Now here we have the square of an expression with the square root. This has a square root of 25. Okay, what number times itself is 25? 5 is. 5 squared is 25, so the square root of 25 is 5. So you get negative 3 minus 5. That's negative 8, square that. Oh, when you square a negative, that's negative times negative, 2 negatives, they cancel. So this will be a positive 64. Negative 2 times the absolute value of 4 minus 8. Okay, this absolute value sign is, it's like, you think of it as a parenthesis. So you do this first before we multiply the result by negative 2. So negative 2 times 4 minus 8 is 4 plus negative 8. Negative 2 times the absolute value of negative 4. Okay, what's the absolute value of negative 4? What is it?
4.
4. Plus or minus?
Positive.
Plus 4. Plus 4. So we have a negative 2 times a positive 4. Only one negative sign, so you get a negative 8.
Hey, Professor, before you go too far, I apologize.
No problem.
Do you mind doing your explanation of that whole square root thing? I'm so sorry. I was waiting for you to take a pause, but you never did.
Okay, thank you for interrupting. This is exactly why I want you to. I want to be able to hear you. Yes.
Not that one. The one before that one, when you like first introduced it.
Oh, okay. Right here.
Sorry, I was like, yeah, right there. You gave some.
Okay.
Some really. Yeah. Go ahead and explain that to me again.
Okay.
Thank you.
A square root of x is a number which when squared equals x. So the square root of 9 is when the square root is 9. Now 3 squared is 9. So the square root of 9 is 3. Square root of 100. What times itself is 100?
Ten.
That's 10.
10. Square root of 100 is 10, you see. A million is 1,000 squared. So what's the square root of a million?
1,000.
There you go. Okay. Let's see. A quarter. Square root of a quarter. What times itself is 1 quarter?
5.
5 times.
No, not 5. Not 5. 1/4. What times itself is 1/4?
Well, a quarter is 25.
Two,
But
2 times.
No. I don't mean quarter like the money. I mean 1/4.
We're thinking money.
And I'll tell you something. If understanding how signed arithmetic works, using your training in capitalist money handling is a great help in understanding how negative signs work, because it was in order to handle money that people started taking negative numbers seriously. See? Yes. All right. A half squared is 4, 1/4. So a square root of a quarter is a half. Does that help?
It does. Thank you.
Not a problem. I live to serve. All right, here we go. Where else? Where are we at? Oh yeah, this monster. Now here we have 3 times bracket, -5 plus twice parent, 7 minus 3 n parent, n bracket. All that divided by 8 minus 5 times 9 minus 7. Now you notice this big old square bracket. It's just the fancy parenthesis. They use that just so you can, so you don't get too confused between which parenthesis is which. All right, here we go. We start from here, and we start by doing all the innermost parentheses. 7 minus 3 is a 4. 8 minus 5 is a 3. 9 minus 7 is a 2. So we have 3 times parent, 9 plus 2 times 4, n parent. All that divided by 3 times 2. Now, all right, in this, the times takes precedent over the plus. So, and 2 times 4 is an 8. So 3 times parent bracket, 9 minus 8n. When you have a long division sign like this, there's an implicit parenthesis in the numerator and the denominator. So the thing here, might as well do this one since it's in an implicit parenthesis. Do it separately. So there it is, 6. 3 times 2 is 6. So 3 times bracket, 9 minus 8 n bracket, all over 6. -9 plus 8, that's a -1. 3 times -1 over 6. 3 times -1 is a -3, that over 6. -3/6, there's a common factor of 3, which you cancel and get -1/2. Okay, we're at the end of this section. Stop the recording. Watch out, weird robot voice. 3, 2, 1.